There is a lot of terminology surrounding AI. Instead of assuming you already know what they mean, in this lecture I invite you to briefly go over some of the most important terms that we will be using throughout the course, just to make sure that we are on the same page. And we're going to begin with AI. It is even in OpenAI. AI stands for Artificial Intelligence and is essentially the simulation of human intelligence by computers. AI enables computers to think like humans and learn new things, solve problems, make decisions, and even create something new which never existed before. AI is a generic term that includes a range of techniques for enabling computers to perform intelligent tasks. The next concept I want to talk about is machine learning. Artificial intelligence and machine learning are related but still different concepts. Machine learning is considered a subset of AI and refers to the development of algorithms that can learn from a provided dataset without being explicitly programmed. Some machine learning algorithms are modeled around the structure and function of the human brain and are called neural networks. This type of algorithms essentially simulate how the human brain works. In this context, we may also encounter the term deep learning, which is part of machine learning. In conclusion, we can say that machine learning is a technique for achieving artificial intelligence. Let's next talk about machine learning models. A machine learning model, or simply model, is the result of training a machine learning algorithm on a particular dataset. Here is an example to help illustrate this concept. Let's say we want to create a model that can recognize whether an image contains a cat or a dog. First, we need a large dataset of images of cats and dogs. Apart from this, each image needs to have a label indicating if this is a cat or a dog. This is our training dataset. Next, we need to develop a machine learning algorithm which aims to identify some patterns. For example, the shape of the head, the texture of the fur, the eyes, and so on. Initially, our model is dumb. Training is like going to school and learning. The model is learning based on the way the algorithm has been created. The output of this training is a model. This is what the algorithm has learned from the training data. If you provide a new and unseen image, the model should now be able to tell if the image provided is a cat or a dog. So to recap, we develop a machine learning algorithm which can create a machine learning model which we can then use on new data. When dealing with OpenAI, we work with models that are the result of training with a particular machine learning algorithm developed by OpenAI. Let's talk about prompt for a second. A prompt is the input we give to a machine learning model to generate output. In the context of ChatGPT, what you type in that text box is considered a prompt. How we write the prompt plays a critical role in the quality of the response we get from the model. A prompt helps to guide the generation process by providing style, tone, and content. If we tell the model to generate funny responses, this will be part of the prompt. So how we design our prompts plays a key role in how we use a model. Next, we're going to talk about tokens. To process text, a model needs to split it in small chunks it can digest. We call this small chunk of information a token. You can think of a token as a word in a sentence. However, this is not 100% accurate. Special characters like punctuation marks can also be considered tokens. Some words are also broken down into tokens. Let me show you an example. This is the tokenizer from OpenAI, which can help us get an idea of what exactly is a token. So I'm going to go ahead and copy, for example, a text that's already appearing here. I'm going to paste it here in this box. What you will see here below is actually the breakdown of this text in tokens. So almost every word is a token, but there are still some words that need to be broken down into multiple tokens. Acronyms, compound words, and words that have prefixes or suffixes are some examples of words that are broken down into multiple tokens. Now, we don't need to concern ourselves with how this happens exactly. Just having a general idea about this concept is sufficient. In this case, we'll see the is a token, but GPT has been broken down into two tokens. So essentially, every different color represents a token. A comma here is its own token. A dot is its own token, and so on. Essentially, if we're looking at this from a bigger picture, we can say that 100 tokens represent 75 words. We need to know about tokens in the context of working with different models and pricing. The more tokens we use, the higher the cost incurred. The models we'll be using can only process a limited number of tokens. Also, the output generated is limited. I hope this brief introduction to these technical terms was beneficial. Bear in mind that the explanations provided are extremely simplified, as the technology behind AI is quite complex. Check the resources folder for additional details, and if there's anything I've missed, let me know in the Q&A.